I think it could safely be said that this one's definitely done its time. And just like everything else in life, there's a bit of a story behind this, and it's actually kind of funny. I reckon I'll share that story with you right now. One of my very long-time computer consulting clients is a little old lady that I've known for about the past 20 years. She stands about 5 foot tall on a good day, and she's in her mid-70s or thereabouts. And evidently, she went back to her bedroom one day to turn this air conditioner on. It had been in their window for as long as I can remember. I'd say it probably dates from sometime in the early 1980s. I don't know how much she actually used it, but I'm guessing, based on how dirty it is, probably a pretty fair bit. She turned it on, it didn't turn on, and moments later she said she smelled something getting hot. Well, there's always some sort of emergency in this woman's life. I'm not going to tell you she's not a lovely person in a lot of ways, but she's always got some sort of a calamity going on, and well, to be nice about it, she's kind of nuts. Look at that, we have a cat that's decided to join us for today's video. Hey there, kitty cat. Anyway, getting back to the subject at hand here, her situation at the time did not put her in the mood for any hijinks from an air conditioner. And so this little old lady, who again stands about 5 foot tall, is in her mid-70s, and is not exactly a world wrestling champion of any sort, proceeded to destroy this air conditioner, or very nearly destroy it. She certainly ripped it apart in the name of getting it out of the window into which it was built. When I walked up to her house to solve some minor computer problem or another, I saw it sitting in the yard, along with a whole slew of other things that went with it. And I just couldn't believe that she'd actually done this by herself. But she did. And I asked her, because I'm presently studying HVAC stuff right now. It's not my profession, but I'm thinking in time it might be a business that I decide to get into, because just like computers, everybody's got heating and many have cooling. And when that stuff breaks down, they need somebody who can do a good job of fixing it. And I've been doing very well in my classes. Very, very well. I really like troubleshooting the most. I know they say you start out as an installer, but the truth of the matter is I'd really like to get straight into troubleshooting and only do installations when circumstances absolutely dictate. We'll see. I'm not sure where I'm going with it just yet, but I'm definitely looking for something that I can do to become gainfully employed on a more regular basis. I love to be in business for myself. Wow, I'm really getting off the subject here. Hello there, everyone. I am, of course, uxwbill, and this is, or perhaps even was, a Kenmore air conditioner. I don't know too much about it, so let's take a look at the nameplate first of all, see if we can figure anything out about when it might have been made. I really thought this was a good deal larger than it seems to indicate, but if I'm reading that plate right, it says that this unit has 6,000 BTUs per hour worth of cooling capacity. I believe it was probably assembled for Sears by Whirlpool. A lot of times Whirlpool was the manufacturer for many of Sears appliances, Sears Kenmore appliances. They still are to this very day, although they've diversified a little bit. Very often when you look inside on motors or other parts, you'll see the Whirlpool FSP trademark, or you'll even see their name. I'm a little surprised it's not on this compressor. I have plugged this in to see what it would do, and indeed it just manages to hum, and it does put quite a bit of voltage drop on the line. It made a few uninterruptible power supplies in the garage very unhappy when I plugged it in. And you know what my thought here is? Either we've got something that's finally given up the ghost, shuffled off its mortal coil, and is probably shorted to ground, or more likely than that, far more likely than that, this run capacitor probably gave up the ghost. Its purpose in life is to introduce enough of a phase shift to give these motors enough of a kick to get up and running and keep them running. It stays in circuit at all times. Now, the proper way to test this would be with a megometer, if I wanted to find out if these motor windings were any good or if they had become partially shorted to ground. But I don't have the luxury of a megometer. I'm looking at getting one, but it seems that even the generic Chinese ones are rather excitingly expensive. So we'll do the best we can with what we have. We'll take the power cord here, which you can see is definitely well into the stages of developing molded plug disease. This woman, like so many other elderly people, has little hellion dogs around the house. Nothing is safe from them, including the power plug on this air conditioner. It's a good thing they never managed to chew all the way through it, because one of them would have gotten to learn a lot more about how electricity works, and most dogs don't need to know how electricity works. But the test that we'll do here is just very simple, and again, not guaranteed to produce results in the case of... Oh, I swear, this cord is giving me fits here. I try to get it to stick around because, you know, I don't have the luxury of using both my hands to work on this. So the first thing we'll do is we'll just stick the meter leads into the plug. And we'll see if we get anything at all. The printing's worn off of these switches, and the thermostat in particular is real stiff, very difficult to work. Of course, getting these to make contact while I'm not holding them in place is proving to be ridiculously difficult. But we do have a resistance reading there, and I would even say it looks pretty reasonable. I would imagine that since I've got the thermostat turned all the way down to 0, that what I'm probably seeing right now is a combination of both the capacitor and the fan motor. But we'll turn the thermostat on. It clicks, and we'll hold our meter leads back in place, and we'll see that the resistance reading has dropped a bit. Again, it's floating around a bit, probably due to the presence of that capacitor. But I would say, at least from a cursory examination, that there's nothing hard shorted inside this unit. We'll go between each side of the line and the ground pin, and we should have a very high resistance reading there, 28 to almost 29 mega ohms. I'd really like to see a little higher than that, but I'd say that's not a death sentence by any stretch of the imagination. So we'll go to the other side of the line here on the power plug, and we'll take a reading there. And we're getting about the same thing, so I'd say there might be a very slight case of leakage here, but nothing that I think would pose an immediate danger to one's life, health, and well-being. This thing is shot. It's really junk. She really messed it up when she took it out. I mean, look at what she did to the condenser coil. I would assume it's still holding a charge. I really have no way of knowing that. But I think at the very least, these dents in the condenser coil are serious enough that they'd probably act as a flow restriction and become an unwanted metering device to the flow of refrigerant. But I'm just very curious, as I am with all sorts of hopelessly dead things like this poor air conditioner, if we could make it live again. So I thought what we might do is pull this capacitor out of here, if I can actually get it. I probably should be a little bit careful how I work in here, because you know what, I haven't had a tetanus shot in 17 years. I really don't like shots. You think that screw will actually come out of there? I'd say it's anybody's guess, but let's find out. Wow. I think it might. That's a... Folks, you just witnessed a freaking miracle. Of course, now I got to get that thing out of there. Another thing that this carcass really drives home, clean these things out every couple of years. You'll save yourself a lot of money, because this poor thing, toward the end of its life, I'm sure it was just beating itself to death, probably had incredibly high head pressures. So you know that compressor was working hard, drawing more current. This fan was working hard, couldn't shed the heat. And it's really a wonder that these capacitors are as reliable as they are, because all in the world that they are is just rolled up layers of paper and foil in some sort of an oil substance. So let me see if I can get that out of there, because I definitely can't do that single-handed. And we'll take a closer look at it. Well, there we go, folks. I got it out of there. It wasn't nearly as painful as I thought. I thought I might be fighting this refrigerant line on the compressor. But nope, I was able to pivot this bracket, this metal strapping up just enough to sneak the thing out of there. And now we at least know how old this air conditioner is. For almost 40 years this capacitor's been in here doing its job. That is pretty darn impressive, especially when you consider how they're actually made. And it definitely looks every bit of it. Supposed to be 15 plus 5 microfarads. I may not be able to test this out after all, because what I was planning on doing, I have a capacitor out of a scrap central air conditioner. And while the fan motor, the fan motor is dead on, I could do that. But this is 30 microfarads. I mean, I don't really care. I'm not necessarily opposed to trying it anyway. And for a short period of time, I'd probably get away with it. I don't know, we'll see. It would be kind of nice to make this thing live again, but it's an academic exercise. This thing will go off to the recycling yard to have its refrigerant properly reclaimed, since I'm not equipped to do that yet. And then the rest can go away as scrap metal. I might save the fan motor. It's hard telling, but let me see if I can figure something out here. Like I say, this is basically twice the rating of what I need. I don't think I have any others kicking around, and I don't feel dedicated enough to steal one out of another window air conditioner unit. Here, of course, is a look at our fan motor, and I show you this not just to show you a fan motor, because I'm sure most of you know what a simple induction type fan motor looks like, but rather you'll notice that this motor was actually designed to be lubricated. See where it says annually, remove oil plugs and add approximately 10 drops of high quality SAE 20 oil at each end. And it even has an arrow pointing to where the oil plugs are. And I think you can be as good as assured nobody ever did that throughout the life of this unit. So for 40 years basically, it provided reliable air conditioning. You can see the bearings in that motor are still quite good. But the real sad commentary here, this poor motor was intended to be lubricated every year. Nobody ever did that. Nobody ever does do that. And yet these permanently lubricated motors in a lot of things are just, they should last forever, assuming that the term permanently lubricated is actually true, which unfortunately in a lot of cases it actually isn't true. They last a couple of years, 6 months to a couple of years, before they start sounding like a lawnmower. It's just a sad commentary is all. So even though I'm about 99% sure that this capacitor belongs in the scrap heap, let's go ahead and make a quick test of it anyway. Now, a word of warning about a test like this: if you make it with the capacitor checking range on a multimeter or even some dedicated capacitor testers, neither of those devices puts a capacitor under anything like its full working load in terms of voltage or current that's passing through. And it's very easy for a multimeter to pass a capacitor that is faulty when it's under load. And really they're so cheap that if there's any doubt, you ought to just replace them anyway. Now there are two ways of doing this. You can, on any multimeter with a resistance testing range, apply the test leads to the capacitor with the meter in its resistance measurement mode, and the resistance values will actually change as the capacitor gets charged up. And if you see that happening, that's generally a better sign than if you don't, or if you read a dead short or completely open circuit. So let's go ahead and put these test leads on here. This multimeter has a dedicated capacitor testing range. We're on the fan side of the capacitor now. That should measure 5 microfarads. The multimeter gave me a couple of low values, and then it seemed to settle at the correct one. But I don't trust that result. I believe that this capacitor is definitely bad. So we'll go over and try the compressor side of the capacitor. Might take a few moments for a reading to show up. Again, it's rated at 15 microfarads. It shows pretty close to that value, but under load I've got to imagine that it's breaking down and not providing the needed boost to get everything off the ground, because startup on these things is by far and away the toughest time for them. Since this value is so far out of whack for the compressor, I'm really undecided about actually trying it. I may hook it up just for grits and shins and see what happens, because I can't damage this thing any worse than it's already been damaged. But for right now, we'll just see if we can get the fan motor to run. Alright, boys and girls, here we go with a smoke test. I've got the switch turned on. And look at that. The fan is running. See the runs in the other speeds. There's low. There's high. Now, of course, before you ever handle any capacitor, whether it works or not, you always want to make sure that it is completely discharged. Again, there are a couple ways you can do this. You can monitor it with a voltmeter, and in a lot of cases you can simply short across it with a screwdriver. Or if you don't like scary pops and crackling sounds, you can use a high voltage resistor on the end of something like a popsicle stick or other heavily insulated item to make sure that you're safe. So the fan motor on this seems to be good. I'm so tempted to try the compressor. It may fry it, but like I say, there's nothing to lose at this point. So let's just hook it up and see what happens. Now, of course, you absolutely should not use too large of a capacitor value if you don't have the right value around. Going about 10, maybe 20% either way is probably okay. But here, we're basically double the needed capacitance. And in this case, the phase shift could be so great that it might start the compressor to running backwards instead of the way that we actually want it to go, which would certainly not do it any favors. But what the heck, life's short. Let's just give it a try and see what happens. Alright folks, here goes. This is the big one. Smoke test! Okay, the compressor started running. And the fan's going. We'll see if it might actually run long enough to build up some pressure and start refrigerating. Looks like fun, doesn't it? I went ahead and got my digital thermometer out. This actually has two inputs on it, so we can take the temperature of both the return and the supply air, and we can read both sensors separately. Or we can ask it to tell us what the delta T, or the difference between return and supply, is. I think you'd want to see that somewhere around 15 to 20 degrees. But for all that this thing's been through, and the fact that it's flowing basically no air through that condenser coil that I can feel at this point, it's doing a remarkable job. And earlier I expressed some concern about these damaged loops in the condenser coil acting as a metering device. I suppose it's possible that one might get away with it just because toward the top of that coil the refrigerant's going to tend to be in a high pressure gas state as opposed to a liquid. I'm not really feeling any temperature difference between the upper and lower portions of that loop, which surprises me, to be honest. But the damn thing is running. It's really a testament to how well these things used to be engineered. Just how much of a beating they'll take. And in the end, it was what, a $10 part that caused this poor thing to quit working? Looks like we're even sweating on the suction line there. Don't do this. This is a bad idea, especially if this decided to have a temper tantrum and explode. It's staying cool to the touch. Compressor's not even getting all that hot. Let's see what happens if we change the fan speed. Of course, if we really want to be accurate about this, we'll let the thing acclimate for a couple minutes. There are other problems. This cord set's getting hot. I wouldn't be at all surprised to find out that maybe the copper in here was having a bad reaction with the rubber and had started to oxidize. Sometimes that's a problem. I don't know, it's pretty beat up. I have most of the screws, but I don't know if I could get it to go back together. I'm not really sure if it's worth it, but Boy, am I tempted to clean it up and try to put it back together again. Maybe even get the right value capacitor for it. Well, thank you as always for watching, everyone. I certainly do appreciate it. And if you have a comment, certainly do feel free to leave one.